In this video, we're going to look at an exam question on implicit differentiation. So how do we differentiate implicitly? Well, if we're differentiating a term that's already in terms of x, so sine differentiates to cos, and so this first term would just differentiate to 2 cos x with respect to x. That's not a form of implicit differentiation. However, this is because this is in terms of y, but we want to differentiate in terms of x. All that you do is you differentiate it as normal, so cos of y would go to minus sine of y. So we'll write this out as minus 2 sine of y, because there is that constant 2 that's being multiplied. But again, because we're differentiating y with respect to x, we then have to multiply onto it dy by dx. That's all you do. Just differentiate as normal, but then multiply onto it d of this term that you're differentiating with respect to x equals, and you also have to remember to differentiate the right hand side, which sometimes students forget to do. From there, all you do is you make dy dx a subject. So we're going to start by adding 2 sine y dy dx to both sides. So we get 2y sine y dy by dx is equal to 2 cos x. You can then cancel out the 2's. You can make dy dx a subject by dividing both sides by y sine y. So we get dy by dx would be equal to cos x all over y sine y. And that's it. That's your final answer to this question. Moving on to part B, it says to find the coordinates where the point dy dx is equal to 0. So when is a fraction ever equal to 0? Well, let's think about it. Can the denominator of a fraction ever equal 0? No, it can't, because that would be undefined. The fraction can only equal 0 when the numerator itself equals 0. Now, when does cos of x equal 0? Well, if we draw out the graph of cos of x, actually, we can see that we're only focused between 0 and pi, and at pi over 2, sorry, this is a very inaccurate graph, but when x is equal to pi over 2, that's when cos of x is equal to 0. So that's your x-coordinate for this graph. And then we need to find the y-coordinate. Well, the y-coordinate can be found by inputting x equals pi over 2 into this equation. So let's do that. 2 sine of pi over 2, well, that would be equal to 2. So 2 plus 2 cos y is equal to 3 at the point where x equals pi over 2, which is at the point where dy dx is 0. Hopefully you're seeing how all this fits together. From there, you subtract 2 from both sides, so you get 2 cos y is equal to 3 minus 2, which is 1. You then divide both sides by 2, so cos of y is equal to half. And then you do the inverse cos of both sides, remembering to put your calculator in radians mode. So let's do that. Inverse cos of a half pi, or just a half, sorry, would be equal to 1.05. And so your y-coordinate is 1.05. That's it. That's your final answer to the question. Do be sure to leave a like if this video helped and subscribe. I'd appreciate it a lot. Thanks for watching. Thanks for watching the video, guys. Hope it helped. If you have any A-level maths or physics tutoring inquiries, be sure to send me a message at www.excellineducation.co.uk.